We're back, we're live, we're here on Wednesday, and you know what that means.
Energy
Wednesday. Whoa!
Whoa!
That's the sound of Sharon Moriwaki. She's my co-host. I'm Jay Fidell. Between us in this kind of sandwich affair is Dennis Furukawa, and his company is RealGreen. Did I get this right? RealGreen Power. Okay, that's Derrick Sonada on the far end.
From Hawaii Energy.
So first I'm going to tell you about our Twitter feed. We have our Twitter feed. We're looking at it. If you want to tweet us something, feel free. It's ThinkTech HI, ThinkTech HI. People do, we have remarkable questions come in. Send us a remarkable question.
I know,
Okay.
I look forward to those questions.
Yeah, well, I hope they're for you. Otherwise, Sharon will have to answer.
She's much better at it.
You've got the answers, though.
Derrick, what do you got today?
I want to talk a little bit about a project that we piloted this past year. It was with
We
Kanu
meaning
Hawaii.
we
Hawaii
mean
Energy.
Hawaii Energy
It's-
and Kanu Hawaii.
I bet you $5 this is
Kanu.
about energy efficiency.
Yes, it is. All about
I
energy
knew that.
efficiency when I talk about it here. But one of the things that we're trying to develop is to develop a group or an employer competition. So we piloted with 5 groups around the island, and we asked their employees to sign up. Then they would get this curriculum of 60 days. They would get a tidbit in their email. They could watch a video and everything else. Then they have the opportunity to go home, try these energy saving tips, and we would measure the results of their reduction at home. So the person who had the greatest percentage reduction wins the competition. So we had a lot of fun with this. Now, one of the things that we had to overcome with this, and Kano is an expert at it, is how do you communicate such a new topic to such a diverse population with both cultures and age and
On
English?
ThinkTech Hawaii.
That's on ThinkTech. That's one way.
We rehearsed this in advance. Yeah.
So Kanu came out with 19 videos that explain
Wow, 19.
about 200 ways to save energy at home with very little words. It was all pictures, it was all examples, and people got it. They really enjoyed this. So from the top CEO all the way down to the person who just came into the company, they could watch this video and they had an opportunity to learn, and not just learn, but implement. We had excellent results. We did get a tremendous amount of feedback coming from this. We're going to look for ways to overcome the barriers that we found. One of the things that we're going to find, Jay, is about privacy of information? Well, people are so private about their energy use. Hawaii Energy, we have access to all of their energy use and their account information. We needed to get their account number so we could let Kanu Hawaii, which was doing the game, into some insight, and it was just about the reduction of their energy, not about how big their bill was, and people just had a problem sharing this. So we're going to come up with new ways of trying to get the information without having to make people feel uncomfortable about giving too much information.
Yeah, that is so interesting. That reminds me of the smart grid equipment on Kauai,
yeah.
where the utility KIUC would know how much you're using. And a lot of people didn't want them to know. They didn't want the smart grid equipment, even though there are huge benefits, they didn't want it installed. And ultimately, you know what KIUC did? It gave them an option. You can do it or not do it, no matter us. But it does matter us, and I think everybody should go along with that. And frankly, I'd be a lot more worried about my trash than my energy use. What are they going to know about me, my energy use? My energy use is an open book. I'm going public on that.
Well, the only thing I got to say, Jay, is what do you have in your trash?
Sorry, I didn't go public on that one.
But anyway,
So what are some of the other barriers? Is that the only barrier? They wouldn't give you information?
That's one of the huge
Really?
barriers to do this. And then what we did find is because we are email-based, we're trying to reach the masses with very little cost to do this. But a lot of employers have firewalls that prevent people from watching videos. And that is something we have to come and find solutions for, that it won't impede their policies within the internal companies, because we have a lot of companies that want this. We're just finding these little things that we got to find solutions for.
I know what Dennis's question is, because we always allow our guests to cross-examine Derrick, and he can handle it. But I'm going to read minds here. I know what Dennis's question is. How can you be sure that the guy who reports his efficiency is telling you exactly the truth? How can you know that?
Well, we monitor their energy use, what they're using at the meter.
Oh.
So you get it anyway.
Yeah.
And meters always.
Right,
tell
and then let's say you signed up for this and you watched the video. We can see you watch the video versus maybe Sharon didn't get a chance to watch that video because she was out of town. We can see all of that in the information flow that Kanu Hawaii developed for us. So we can say, oh, it was fair because Jay watched all 19 and you watched all 19, but Sharon blew Jay's doors. She saved so much more energy. Jay's one went up. So we can
But-
kind of see all of that.
You can see what I
You
watch?
can see what
The videos that you watch.
That's
So
like.
only the
looking-
videos in the curriculum.
Wait,
So we have 19 videos.
so they're doing it at home
They're doing it either at home
or at work?
and at work. But what we're finding out is not many people have computers at home.
Oh, really?
Yeah, it's more for somebody else at home, but the breadwinner or the worker, they may not be using the computer. It might be for somebody else in the home. So
Interesting.
they're not comfortable in that media yet.
Yeah.
Yeah, we learned quite a lot.
Dennis, how about a real question from you? What do you think?
Well, so is this a device that you plug in at the meter, or is
No,
this?
since Hawaii Energy, we're the State of Hawaii program, yeah, that goes out and implements energy efficiency and conservation. We have on our side all the information for everyone's account usage and everything. That way we can monitor success and we can see where the problems are. And we're very, very, very cautious about that information. Nobody else but our team can see it. But to do that, to share it with Kanu Hawaii or partners that want to implement, we have to get their permission. So if Jay wants to do it, he signs a paper saying, I give somebody, Kanu Hawaii, for example, permission to see my energy use, not the dollar amount, just the energy use for so many days so that they can run the competition. But just that one request was a huge barrier.
But why do you need their approval if you already have the information?
We can see it, but we have to share it so we can tell who won.
Oh, I see.
Otherwise, if I just know, I can't share that you won the competition. We need permission for that. So we're very cautious. We try to be the best stewards possible with that delicate
That's good.
information. Yeah.
That's good. Mm-hmm.
Yeah. So that was a competition. We hope to make the refinements and roll that out again so we can help more people.
What's the prize if I win the competition?
You get to be on the show. Actually, it was really good. The different employers, we gave them a small prize for it, and the employers all kicked in some additional
Like
prizes.
cash awards.
Or gift certificates or whatever that they wanted to do, and it was a good morale booster. The employers loved this because it's something they could do together, and because it was percentage, it's kind of like if Sharon and I had a weight loss thing. We did pound for pound, poor Sharon should never win, but because it's percentage, they have a fighting chance.
Of all the employees.
All the different things, yeah. But I do have to say, we did see one barrier, and then we'll turn it over to the regular show, is people who have PV, we can't tell how much energy reduction they had because it depends on how much they produce. And the sun can be really strong, the sun can be, and we would need to know exactly how much they're capable of producing. All of that information, we don't have enough of everybody. So those are some of the,
But you will when there's a smart grid out there.
when there is one, yes.
You just tap
just a
into
matter of
that
time.
data and you'll have it all, yeah?
Oh, yes.
So how many employers you said volunteered for this?
We did for 5 different groups, and we had quite a number of people, it was a little over 400 if I believe correctly. That
400 employer or
people
employees?
inside, employees
Ah.
within the groups all signed up for all of these things, and it was wonderful. We
Wow.
learned quite a bit.
Yeah.
Yeah, people are hungry for the knowledge, but people don't want anybody to know too much about them, which is understandable.
But do you know what the strategies were that were most successful?
Yes, I do. So a lot of people really unplugged things that they weren't conscious that were in there. Number one, that was a simple one. Everything else. Then people got conscious about how long they were taking showers and their hot water usage. And even with if they had solar hot water, they were very now aware that when the sun is cloudy, the backup uses the old-fashioned elements, and they turned those off. They took cold showers because they didn't feel like in the summertime they needed to be a little hot. They just turned it off. So they found a lot of ways. One family implemented everything that she could, and the kids were like really great. They all pitched in. They wanted to know how they're doing in the competition. It became a family thing to do.
So were they getting feedback on how much they used? I mean, what
We
information?
didn't have that information in this round. The next time we'll build in that feedback.
Because then that would give them more incentive.
Because everybody wanted to know, every week how far they were progressing. So
Well,
we'll build that.
we progressed about as far as we're going to on
Yeah.
this show here.
I know.
Okay.
You got to turn this over.
We're
to
going to
them.
turn this over.
Oh, that's
Yeah.
very interesting. That's why.
Well, we're always being
More.
kind of cutting edge at Hawaii
That's right.
Energy. You
That's
know
great.
that,
We
right?
know that.
We want to win
We know
another
that.
award in the
That's
future.
right. That's
We
right.
do.
See, all right.
Okay, come back soon, Derek.
I will.
Take a
Thank
short
you.
break. Don't leave yet. We're going to take
Oh.
a short break, then leave.
Thank you,
Derrick
Derek.
Thank you.
Sonada from Hawaii Energy. All good things. We're going to take 1 minute off. We'll be right back.
Hi, I'm Ethan Allen. I host Likeable Science on ThinkTech Hawaii, and I do this because I care about science literacy in Hawaii. I want to spread the understanding that science is a vital and interesting part of everyone's life. I want to make sure the broadest possible spectrum of people understand the beauty and the value of science and realize that science plays out each and every day of their lives. I want you to understand that science is fun. So we bring onto this show each week guests who are scientists, from astronomers to zoologists, and we talk about what they do and how they do it. But most importantly, we talk about why you should care about their work, why you should see that their work has value and impact on your life. So I hope you'll join us Fridays, 1 p.m. here on ThinkTech Hawaii. You can watch us via live stream. You can watch us recorded on Olelo, and you can see us each week. We hope you'll join us.
Aloha, my name is PJ and I'm the host of Hawaii Sports Update. I am very interested in local sports, and that's why I host the Hawaii Sports Update show. I bring in guests from Hawaii, I bring in guests from UH, I bring in guests from the community, I bring in big names, I bring in small names, I bring in all names that are community related and doing positive things, sports related in the community. Come join me every Tuesday at 1 p.m. here on Hawaii Sports Update. You can also join me on my golf tournament, the first annual PJ Sports Radio Show golf tournament. It's going to be held at Coral Creek. For any information, go to ThinkTech Hawaii, INC, and friend us. The PayPal and a summary of the event will be right there available for you. And don't forget to tweet us.
Here we go. We're back, we're live. We're here on Hawaii, the state of clean energy, every Wednesday, 4 to 5. And today we have Dennis Furukawa, who is RealGreen Power. We're talking about sustainable water technology, and water is more than just drinking water. Water is all kinds of water. So Sharon, Moriwaki, and I are going to find out today what Dennis is doing and how it affects us. So the first thing is, why are you doing this?
Oh, I'm extremely involved in water. I spend my time in the water cleanliness, and you know, having water to drink, water for agriculture, water for power, water central to really everything.
Are you worried about water?
Absolutely. It's my background is an architect in California, and I was spending a lot of time trying to get developments permitted, and the central issue that was always in a long-term problem was, do you have a water resource that's going to be sustainable, and can you deal with the disposal of your wastewater? That would actually bottle up, you know, especially large projects for years and years and years.
Yeah. Well, it's worse now.
Absolutely.
I mean, California's in deep kimchi about that.
Absolutely. And it's not just California. I mean, the whole, you know, climate change is really affecting our water resources. And it's not just water, it's fertilizers and whatnot, because we import fertilizers for agriculture, and for the most part, those things are being produced unsustainably. Phosphorus is a hard rock material that has limited resources. Nitrogen fertilizers are produced from natural gas. We import all of that.
We shouldn't be using these chemicals?
Well,
these
you
elements?
need them. They're central to life. But what we do is that we waste, you know, every bit of it practically that comes to us in the form of food. You know, everything that we excrete goes into the ocean here in Hawaii, or, you know, in your cesspool or your septic tank. It's not used productively. So my mission is to create sustainable water practices and to eliminate all of those, you know, those waste points.
A footnote on phosphorus. Craig Murphy from Blue Planet Energy, which is selling the blue ion battery from Sony. That is not what do you call the most advanced kind of battery? Lithium battery. So lithium and phosphate. Phosphates are in that battery. Mm-hmm. That's the secret sauce for Sony.
Lithium ion phosphate.
Yeah. So I mean, my guess is we're gonna want phosphates going forward for those batteries, and this is an easy way to get them.
Well, one of the big concerns is that if we're putting, all of these materials in our batteries, then they're not available for food. So there becomes a question as
Competition.
to
What would you
right,
like to have,
question-
light in your house or food?
There you go.
It's a
We've got
choice,
we've
you
got a
know.
lot of those choices going on.
Or water. What do they say? You can get along for a while without food, but water you need pretty quick.
Absolutely.
Was it 3 days or you're dead? Something like that,
yeah.
yeah. Okay, so the other thing about California, before we leave California, is that San Diego has made some enormous strides, spending a lot of money doing, what do you call it? Seawater into fresh water. What's that process?
Reverse osmosis or desalination.
Desalination. And they're spending billions. I mean, I don't know if they've already got it, but I know they were planning it, and it's a big
They
deal.
just opened one up, yeah.
Is that right?
Mhm.
Yeah. And I just wonder where that fits in your universe of water. Because it could solve a lot of problems, couldn't it? It just need a lot of energy for the desalination.
Well, there you go. Energy becomes the crux. And then again, if you're going to spend all of that money producing this fresh water and you're just going to flush it down the toilet and only use it once, is that really the best thing to do? So what we're trying to do is to reclaim it at the sewage treatment plants and to process it so that it's good to replace all of the irrigation water that we're using.
Not my
So-
drinking water, though, that's not,
Right. So,
Promise
right. Well, when you take a look at it, right, irrigation water is the lion's share of the water usage, and where you have groundwater that's available for drinking, you can use that for drinking, but don't use that for agriculture if you don't have to, and put nutrients in it. It's all available.
so
in
it's
the sewage
water
treatment.
efficiency.
Absolutely.
And
Well, it's resource. It's reusing the resources that we have, so that extends the lifetime of the resources.
yeah, we need this badly, don't we? Every
Absolutely.
society needs this, because in the future, if we don't do this, we're gonna have trouble finding water, and we're gonna have wars over water, and people will be very unhappy about not having water.
Well, it's already going on, so
Yeah,
it's not hypothetical.
No, that's why you got into this. You knew.
Well, for sure, because the signs have been actually there for a long time.
Well, California constantly looking for water,
Yeah.
right?
Oh, the poor
Droughts.
aquifers under all that agricultural land, soon enough, they won't be able to do agriculture.
It depends on what we do, how we manage those resources.
Okay, so how does the company handle these challenges? That is the RealGreen Power.
We've spent the last 3.5 years putting in technology and piloting technology over at the wastewater treatment plant over by Sandy Beach, the East Honolulu wastewater treatment plant. And there our system was proven, just to back up a little bit, it's anaerobic digestion. And that is an alternative to aerobic types of digestion, which require a lot of air to be pumped into water. In anaerobic digestion, we have a benefit where we don't require energy to remove the pollutants, and a side benefit is that we don't produce the sludge that is typically produced in aeration, and
It's everything you want.
well, it reduces the energy cost by half, and it reduces the sludge production by over 85%.
And this is done with the miracle of microbiology.
Yes, we're making slaves out of these microbes that don't require
Do they get a
air.
minimum wage or anything?
They get to eat. Yeah.
They get to
That's-
eat
Free
as much as
food.
they
Free
want.
food, right. Yeah, we feed them crap, and they're happy.
And they love it.
yeah.
Literally.
Yeah. So,
How do you do it? I mean, so I have a machine, and I put all the stuff in, and it all interacts, and the
little microbes.
bacteria do their thing.
Can you
And-
see the little microbes going?
No, that's in the video game. No, we use sealed vessels, and those sealed vessels actually capture the stink. And so
That's another good reason to have an
It's a really
anaerobic,
good thing.
yeah.
Yes, absolutely. And that stink that is generally being produced has a good proportion of methane in it. So that methane can
Save
be
the
used.
methane.
Well, yes, we collect that methane and it can be used for energy production. And one of the things that we're looking at, and one of the reasons why the state invested funds into RealGreen Power was because that methane can be converted into hydrogen. And so we're looking at various ways of reprocessing wastes so that it fits in nicely with either electricity production or possibly transportation fuels production. We can reduce the operating costs of the sewage treatment plants and overall recapture a lot of valuable resources in the form of fertilizers and, of course, right, the water that can be reused.
Yeah, this sounds like a great system, but it also sounds like you actually haven't done it yet. Have you done it?
We have been running this pilot for a number of years.
Does it do all that?
Yes, it does.
Oh, we have to talk more about that.
Did you bring pictures of it, or you were sending something? Were you sending anything that?
Well, actually, we have a diagram, but
Well, not it in action, the microbes.
you know, there's
and
really
everything.
nothing to see because they're sealed vessels,
Oh,
and they are
opaque.
opaque.
Oh.
Yes, so basically all you can see is water going in and water coming out.
Oh.
Everything else is.
But you know you
absolute-
put that crap in there.
Yes, absolutely, absolutely. And the good thing
Water
is.
in and water out from all that's in there.
Yeah, the good thing is that we can take a range of wastewater types, some very low strength, which is characteristic of domestic wastewater, and we can put in very high strength wastes. And the two objectives would be in treating wastewater from sewage would be to create clean water so that it can be reused. And the objective in putting in high strength waste would be to produce as much methane as we can.
So the methane that comes out, how have you stored it, or how is that being actually used?
Right now, unfortunately, all it gets done is flared. We're looking to, well, actually, so the next step for us is that we have a development in central Oahu where there's a village, the Kunia village, which was the Del Monte pineapple plantation. And the village there is connected to a sewage treatment plant, a very simple type of sewage treatment plant. It's called a trickle filter. And it of itself doesn't have any energy production, but the water that will actually, so we're going to replace that sewage treatment plant with the same sort of system that we put in over at the East Honolulu wastewater treatment plant. And the objective there would be to recycle all of the water that gets used at the, or is generated at the village. And by putting in the wastewater treatment technology that we have, we're able to treat high strength waste, like for instance from the rum distillery, which I was talking about. The rum distillery has a high strength wastewater that can't be adequately treated with the existing wastewater treatment plant. We can add food processing centers. We can add waste from slaughterhouses. We can take very difficult to treat waste, and that will enable the the creation or the opening of businesses that otherwise wouldn't be possible without that capacity.
Really interesting. I heard something on NPR this morning, I think, about a fellow who was working on creating energy out of carbon dioxide and water. Don't ask me exactly what that process was. It was at one of the big research centers on the mainland, and it worked. And he was refining it now. And at the end of the day, he'll have a kind of a Rube Goldberg kind of contraption that will actually do that. And I think, you know, I'm not saying your thing is Rube Goldberg, but I'm saying that that science is coming up with these machines, which take one kind of thing, which is not so helpful for us, and make another
Converting
kind of
it, yeah.
thing, and there's no detriment to the environment. And wow, you know, this should change the world. And in that regard, when we come back from this break, we're going to find out from Dennis Furukawa how it will change the world. We want to examine exactly how he sees this affecting our society here and elsewhere. Okay, that's Dennis Furukawa. He's RealGreen Power here in Hawaii. Here in Hawaii, the state of clean energy. I want to connect it to energy too, right? Beyond the methane.
Absolutely.
Okay, and we'll talk about sustainable water technology, which will become more important to you by far as we go forward. Okay, we're going to go forward to a break.
Aloha, my name is Jim Shawn, and I'm host of a show called Education Movers, Shakers, and Reformers. Each week, live streaming at noon on ThinkTech Hawaii, we interview people who have special insights into education, from early education through K-12, all the way through higher education and beyond. Both public and private are areas we're interested in. We dig deeper. We try to find out what it's really like to be involved in making change, advocating for it, how you reform, what people's philosophies are in reforming it. As I said, we're live streaming every Wednesday at noon on ThinkTech Hawaii. And later on, you can find these interviews on YouTube and on the Hawaii Educational Policy Center website. We hope you join us as many times as possible. Aloha.
There we are. We're back. We're live. We're here with my co-host Sharon Moriwaki and Dennis Furukawa of RealGreen Power. That rhymes with Furukawa.
It was intentional. Yeah, absolutely.
And talking about sustainable water technology, which is going to be more important. But I would like to ask the question that we left cliffhanging. You know, how am I going to see your technology, pervade through the community? How is it going to change the way we live here in Honolulu?
I think the first thing is that you will see it over in the Kunia village, and to see it both creating opportunities for extending our resources, that being, producing clean water, but producing renewable energy through that system by taking these high-strength wastes. But more importantly, more significantly, we're looking at the situations at the Honolulu wastewater treatment plants, both the Sand Island and the Honolulu wastewater treatment plants, and specifically the Sand Island wastewater treatment plant. One of their greatest expenses there is the energy that they're spending on disinfection of the effluent before it gets dumped out into the ocean. They're running ultraviolet disinfection there. And the amount of energy that's required to disinfect that water is proportional to how cloudy that water is, the opacity of that water. And our system is highly effective at treating the wastewater without producing the amount of solids that create that opacity. So by putting a RealGreen Power system in to treat the wastewater before it gets to that disinfection part, we can dramatically reduce the amount of energy that's being used.
But can you do this in scale? Can you do?
Yeah, we're working to scale up. Yes, our technology.
Can you handle all of that with these closed
They can
systems?
absolutely be designed to that scale.
Because, I mean, it's running water, right? It probably runs at X gallons a second in a minute.
They're looking at about 60 million gallons per day at Sand Island. I think between 40 million and 60 million gallons.
If I have one of these closed anaerobic tanks, how big is the tank, and how quickly does this reaction work with the microbes?
We've gotten the process down to be just about as quick as the processing times at a traditional sewage treatment plant. So it's been a great improvement in anaerobic digestion technology. The time that we're looking to process the waste is about 6 or 7 hours for the anaerobic portion. Let's call it 8 hours, which is just about 2 or 3 hours longer than the aerobic portion.
How much does that involve when you say 8 hours?
So if you have a million gallons of wastewater, you would have a system that would be 600,000 gallons or 400,000 gallons of capacity.
Big tank.
They're very large. They're very large. But then again, the sewage treatment plants take a lot of water a day, and they produce a tremendous amount of sludge, and that sludge needs to be removed. And for a long time, it was being discharged or taken to the landfills. I'm not exactly sure what's going on with it right now.
Building materials.
Is that right? Yeah. Paper, right?
Why not? Yeah, paper.
Yeah.
I'll skip the paper part.
Okay. All right.
I mean, we know it doesn't go to make peanut butter or anything.
Yeah.
You don't know.
Recycled toilet paper.
There you go. Wait a minute, this is pretty interesting that you could scale up big enough to actually, sort of process everything that comes out of that plant. So what does that mean to me? Why do I care?
Well, the number one thing, if our system is proven to reduce the costs of operating the sewage treatment plant, the energy cost by 50%, that means a huge amount. I mean, the sewage treatment plant, I believe, was 5 to 7% of the entire city budget to operate the energy cost of the sewage treatment plant. So, and that's at the current processing.
This means my real property tax is going to go down.
Well,
Yeah, right.
but in order for so the city and the county are under a consent decree with the EPA to install compliant treatment technologies, which have the potential to actually double or triple the energy costs that the sewage treatment plant currently
Pay for clean.
Right. So it would be a good investment to apply.
Replace that
Yes,
old
to
technology.
actually to replace the new technology that they're going to be putting in.
Oh, they'll put it in anyway, and then
They're going to put
after
in
a
new
time-
technology that doesn't
replace-
work as effectively as yours, and then have to change it out?
Well, but it has been proven, right, over decades that it is a safe and compliant technology.
They don't believe it.
Well, I think it's really a matter for us now to demonstrate, our system at scale.
Where are
So-
you in that? This is the question I was going to ask.
Well,
Where,
so-
have you finished your advocacy here? Does everybody in the city agree? Are they ready to? Is the city council ready?
We have not actually approached the city council. We are at a place where I think it's appropriate. We're going to scale our system up at the Cunha Village, taking it from a pilot to an actual completely reliant community sewage treatment plant. And at that point, it becomes, I think, very appropriate to then scale up from there.
How big is the Cunha Village?
So we'd be scaling up to about 60,000 gallons a day. So still, there's a big leap between 60,000 gallons a day and 60 million gallons a day. But it's really just a matter of replicating the technology.
So is this brand new kind of thing? I mean, are you pushing the envelope right here in Hawaii? Are you inventing new technologies to do this? And I mean, you'll have to build it. You'll have to build it, won't you?
Absolutely.
So
this is technology that we've developed in cooperation with the University of Hawaii, the Hawaii Natural Energy Institute.
they're everywhere, those people.
Those guys are great, and the manufacturing techniques to scale up the project are actually things that are activities that are underway right now. We're really trying to drive the cost down for each treatment vessel, and by the laws of volume and surface area, the larger the volumes that we can create, the cheaper that those tanks are going to be.
What were those laws again, Sharon? What was this, surface
The
area?
greater the greater the volume, the smaller the surface area.
Okay. We have some pictures. Can we see the
Oh,
pictures?
that's
Maybe Dennis can
okay.
describe what we have on the pictures here.
Well,
This is your
that's
system.
a
This is
poorly
your-
tweaked
Oh.
diagram, but indeed, what we're saying is that farms and energy require water. That water, or the products from the farms and energy go to people. The people take those products and they create waste. Farms create waste, energy creates waste. Those things can be reprocessed, and we can create a sustainability if we treat those waste products.
It's like a miracle, isn't it?
It's really,
It was
it's
thought of
taking
50
the
years ago.
lessons
So
of.
where does your equipment?
We're in the
aerobic
center.
You're the recycled resources
Yes,
there.
yes.
So you'll be like, when we're talking about the recycled water resources, that comes in after you put all of that waste into your system. Is that right?
We can take farm waste. We can take the waste from people.
And I'll just you put all of that in.
Right, and then we can create energy products and recycled water. So we're right in the center.
So
of
is
all
that, how is that different from H-Power that gathers a lot of the waste
Good
as
question. H-Power actually is a solids waste handling system, and so it doesn't really work for them to be treating.
This is like
to try
green
to-
waste. This is just green
Right,
waste?
we're in the water treatment sector.
Wastewater.
Wastewater.
Treatment sector, right? So all of the things that go down the toilet don't make their way to H-Power.
Yeah. So H-Power is really a different thing.
Well, in a way, they're kind of
Trash.
complementary. I mean,
Right.
from my point of view,
They do the trash.
you deal with the water fraction with the appropriate means, and you deal with the solids fraction with the appropriate means.
I went to the Hawaiian Electric peaking plant in Kapolei one time, and it's right next to H-Power. And I kept smelling what I thought was a restaurant. It had this wonderful organic, I mean, it was good.
Maybe like,
This
not French
organic
fries.
smell,
then.
it's like
Oh.
French fries, whatnot. I said to the guy who was giving us the tour, I said, gee, you have a restaurant here? It seems like a fairly remote place for a restaurant. No, that's H-Power. But you don't have any smell at all, right?
That's the goal too.
Yeah.
Yes.
You know, a funny thing is that we had this panel in the Asia Pacific Clean Energy Summit. You must have been there on your account, and you spoke.
No, not I.
And anyway, so I'm talking about distributed energy, and the issue there is you want it big, you want it little, do you want it at the user end, or you want it at the utility end, and what goes in the middle, and how do you distribute all this equipment, all these processes, in order to make maximum efficiency for energy, and especially renewable energy. And I'm just wondering, you're talking about scaling it up. What about scaling it down? What about a little one, about that big? $50.
It certainly is possible. It's this, the microbes can fit in something quite teeny. So that's not the problem. But we're really focused in on where are the big waste, where are the resources really being wasted? And by taking our fresh water, our precious fresh water, using it once and pushing it in the ocean, it's really, externalizing one, our pollution problem, and then two, it's depleting our water
Yeah,
resources.
we got to do better, especially
Yeah.
in an isolated island state like this.
Absolutely.
Because we have to avoid that process again. the way you make fresh water out of seawater.
Yeah, desalination.
Desalination. You have to avoid that part because it takes so much energy. It's so expensive.
It does.
To build it and operate it is just huge expense. And I mean, someday, a lot of people say someday we're going to have to do that. But if we can stave that off with systems such as yours, that would be a much better thing.
It would be, because desalination creates a saline discharge. So you're creating imbalances if you're discharging that back into the ocean.
Okay, the one thing that strikes me though is the economics. This is we all hush our voices and we start talking about money. This did you say 60 million or 60 million gallons? It's a lot of money. I mean, to build a system that will handle that capacity. I know in LA it'd be more, and in San Diego it'd be more.
Yeah, well.
But where are you going to get the money to do this?
Well, I mean, if you actually take a look at it, in order to bring the city and the county in compliance with the EPA mandate, the city and county has set aside over $1 billion to upgrade the sewage treatment plants. So the money is already set aside; it's already earmarked. The question is are we going to spend it on something that is going to be affordable in the OpEx? Or is it going to be something that is, going to be, cheap on the front end, and it's going to be like a printer?
We're going to spend the money. Let's spend it on the most efficient technology.
Absolutely. But
that's a sort of hanging question from before. Can't you get into this, call it governmental process, and get them to spend that money on your technology instead of technology that'll have to be replaced?
We're certainly working on it.
Okay, that's the DI camera. Some people call it the KC camera. DI stands for David Ige. Today, let's make it the Kirk Caldwell camera.
KC.
The KC camera. And why don't you take a moment and just talk to him, talk to the man, and tell him what he should be doing now.
To fund
Okay.
this.
It would be highly appropriate to take a good hard look at the alternatives that are before us, and especially taking into account the resources that are possible to recover from the sewage treatment processing. The capital costs are going to be expensive no matter what, but the question is are we putting in systems that are going to be affordable in the long term? Are they going to be durable in the long term? And can we actually have an investment that creates further economic opportunities? So I believe, and we all believe that my colleagues and I believe that we have a tremendous number of resources that are just being washed out to sea.
Literally.
Absolutely. And we can create a tremendous growth in agriculture, especially in agriculture here in Hawaii. And not just reduce the amount of imports that we have, but actually turn the balance of trade around and create exportable products from Hawaii.
Including technology.
Yes. Now, if you take a look at it, so in science, we do something called mass balance. So we import millions of tons of food and consumables here in Hawaii every year. And anything that we eat, that amount of mass is going down the sewers, and it's being wasted. And so if we can harvest that mass of nutrients and real value and put that back into production, growing things, there's absolutely a huge potential. Now, if we were recycling the water that was going out, that 60 million gallons a day, and actually recycling it through agriculture in greenhouses, in hydroponics, we could have billions of gallons entrained within a agricultural system that is taking nutrients, out of and keep preventing it from going to the ocean, and creating products that we could export.
Okay, we're out of time. Thank you, Dennis. Thank you, Sharon. That's Dennis Furukawa, RealGreen Power here in Hawaii, the state of clean energy, talking about sustainable water technology, and I am sure that Mayor Caldwell was listening carefully. Thank you so much. Aloha.
Thank you.